Welcome to our dialogue session today on AI and its application in the medical field. In this pandemic, AI has been a critical force multiplier and game changer for everyone. Trends, conversions, pattern recognition around the clock and beyond what teams of humans could do. Without AI, this pandemic would have a repeat of what happened in the previous centuries. But today, we are different because we can teach our tools to become extremely good at very specific tasks that have clear parameters. Today, we will be delivering to discuss different scenarios of medical applications across different parts of the value chain. We will analyze what organizations have done in their front lines in the hospitals and in their academic research. My colleague Moritz would present himself and introduce himself.
Yeah, okay. Thank you, Faisal, for the lovely introduction. I'm just going to start with a short slide on my background. So my name is Dr. Joseph, as you already have heard. I've made my bachelor in medical engineering at a German university in Lübeck, just as Faisal. That's from where I know him. Then I also did my master's there in computer science, and then from 2014 to 2019, I did a PhD in electrical engineering in the field of computer architecture, which was the first thing where I worked on emerging technologies, namely 3D integration and interconnection networks. And then last year until this year, I worked as a visiting researcher at Georgia Institute of Technology in Atlanta, Georgia. And there, well, I just designed hardware for AI accelerators. So with this postdoctoral experience, I actually do have quite a broad knowledge in AI accelerators in general. And yeah, should I start with the talk now, Faisal, or do you want to give some additional words?
Go ahead. Go ahead.
Okay. Thank you all for your kind attention. So as introduced in the in the advertisements for this talk, we are going to cover 3 topics. The first is on the German experience with AI in the areas of medical research. So I'm going to give a little bit of an overview on the current situation in Germany, trends and challenges for AI in the medical field, and the strategic plans in Germany in general. Then in the next part, I'm going to give a vision about artificial intelligence applications in the medical field. And as Faisal told me that you have heard quite a lot about hardware and algorithms in general, my idea here was to focus more on the hardware side, especially as in the medical field with medical robots and imaging devices, hardware plays a very important role. And finally, and this is the part where I'm going to head over to Faisal again, we want to talk about ways to benefit from the applications of artificial intelligence in the health field. And so basically, this is on medical applications for AI. And starting with this outline, I'm going to directly dive into the talk and give you a little bit of a foreign experience here, hopefully, especially the German experience with AI. And I want to focus on how the political, social, and economic situation is shaping the research and the development of AI in Germany. Yeah, well, I think you all know where Germany is located. It's somewhere in the heart of Europe. I thought just it's nice to give you like a little geographical overview here. We have 82 million population, and it's about 4,000 kilometers away from Riyadh. So it's quite close, but not too close at the end of the day. And yeah, I think the German society it's important to understand how the German society is, of which kind of people it consists, to understand our quite special approach to AI. So the first thing is that in general, the German society is relatively old, as you can see on the slide here. And on the other hand, it is quite rich. So we have a very high GDP per capita in international comparison. We have a very low unemployment rate. and also the education level is quite high. So 86% of the country's 24 to 64-year-olds have obtained at least an upper secondary qualification, and this is, I think, quite important. So it's an old society, a rich society, but also a well-educated society. And but on the other hand, I think that's kind of something interesting. The share of internet users has been historically quite low, as you can see here. So currently it's like 86%, but I think it's still quite a low number that only 86% of people are actively using the internet. And also there are quite a lot about concerns in general about privacy and data security of AI in Germany. So what you can see here in the figure is the number of people who think that AI is either very safe or rather unsafe. And as you can see, the vast majority of people think that the application of AI in general is rather unsafe. And I think that's an interesting find to see that this society is rather reluctant in terms of AI, which is, I think, something that is very different in comparison to Saudi Arabia, where people, I feel like, are more positive about the application of AI and emerging technologies in general. So what does that mean in terms of the economic infrastructure? And again, I already said it's quite a rich country, Germany. So we have a quite high GDP of 4,040 billion last year. And we have a strong background in manufacturing, in supply chains, in production chains, in automotive and chemical, but also in medical applications. And what you can see if you take a look at the shares of the GDP in Germany, you see that services have a high share here, just as in every Western country currently. But what is the interesting find is that production still has a quite high share, with 1/3 of the GDP of Germany. So what you can see is that this production is still an important sector, especially in comparison to the US, for instance, where it's only 18%. And this is due to one important reason, which is we have quite a lot of small and medium-sized companies. We call them Mittelstand in Germany. That's like a super German term. But again, these are small and medium enterprises with less than 500 employees, and those generate about 50% of the GDP and provide more than 50% of the jobs. And I think the important part here is that you may not underestimate these small German companies. They are, in most of these companies, are world market leader in their specific thing they are doing, while they are mostly not known to the general public. And I think this is quite interesting because small medium enterprises struggle to innovate and scale, and this is something that is especially true in highly competitive environments such as AI. So what you can see from these two slides is that Germany is quite in a unique position, where it is in a situation where you have a rather old society which is reluctant towards AI, but you also have a lot of companies which find it hard to adapt to these new technologies. So what the German government does to account to that is that they have a strategic plan, and this is based on our research infrastructure. And I want to give you an overview about the research infrastructure, just to give you an idea about how we educate people in Germany, but also if you're looking for potential partners for academic projects or for industrial collaboration, where you can attach yourself and find probably interesting partners. So these are the 5 most important research institutes in Germany. Max Planck and Helmholtz, I just mentioned them here. They're doing basic research, so probably they are not of such a high interest for you, but more interesting are Fraunhofer, which does industrial research. Then we have the German Center for AI, which is a specific center for AI research, and is actually the oldest center for AI research in the whole world. It has been founded in 1984, which is quite old in this field, so that's quite interesting. And we have a specific institute which is only focusing on IT research with a very strong focus on AI. So if you're looking for partners, those 3 are probably the addresses to go to. And on the other hand, from like the states, we have universities and applied universities, and probably some of these universities such as Munich, Aachen, KIT, you might know these universities because they are quite famous. And again, this is quite a diverse structure in Germany, so I can't really tell you like go there. Just you have to actually do your research. But in general, the universities do basic and industrial research, and the applied universities just do the engineering. So this is not the interesting part here. And from these 4 drivers, namely Fraunhofer, the German Center for AI, and the Hasso-Plattner Institute, but also the universities, the government is hoping for an economic impact in terms of AI. So if you're looking for potential partners, I would go there. just to like have some names dropped. So I hope this provides some value for you. On a more general purpose, in terms of trends of AI, what you probably have already seen in many slides here is that the revenue from artificial intelligence software has increased in the last years a lot, and everybody expects that this trend will continue. As you can see here in the slides, for 2019 until 2024, the projected market revenue in billion US dollars is really high. And also the growth forecast for AI software looks great. As you can see, it's every year we expect quite a high growth in this market. So it's a really nice market. And the interesting question is, how can you shape this market? And I think one of the key factors is that you have talent for that. And this is why I took a look at the number of AI experts and talents by country. And as you can see, Germany is scoring here quite well. Worldwide, it's on place number 4. And especially in relation to the size of the population in Germany, which was only 80 million, I think this is a really nice number that you can see that Germany has such a high number of experts and talents here. So I think Germany is a very good partner for you if you're looking for that. But again, we have this large skepticism towards these ideas. So what you can see here is how much do you agree that artificial intelligence should be employed in daily life, from agree to neutral to disagree, and the share of response for, well, a study here. And as you can see, Saudi Arabia is again scoring here quite well, while Germany is not. So I think that's quite an interesting situation where you have a lot of talent and you have a lot of industries that are already working with the technology, but on the other hand, people are reluctant to adopt these new technologies. So let's shift away a little bit from like this general trends and focus more on the medical applications. And I especially want to highlight the central topics for academia and also for research in Germany in terms of AI in the medical field. And I think there are 4 very important ground-laying things that you find a lot in German industry. The first is that our manufacturing industry is quite strong, and so they are interested in AI in general. And this can also be used in medical field, as we are, for instance, providing very good already told, but I wanted to highlight them on a separate slide here because I think robotics in the medical field is one of the most important parts for innovation. And also sensors is important because only if you have reliable sensor data about your patients and about what's happening, only then you can actually use the AI systems and to work with these data. And as I told you, this is like the 4 important markets in Germany where we do innovate. And this is again represented by the share of first-year students in the first university semester in Germany last year. And as you can see, I mean, okay, don't look at the law and economics numbers, but the second largest share are engineers. And I think engineers are the important people shaping this, shaping AI in the medical field. Engineers will be the talents in the future which will steer the field and provide the most innovation and new techniques here. So I think, again, Germany is quite a nice partner for that. So I would like to highlight 2 things, like a little bit away from medical, but 2 important innovations that we have shaped in the last years, just to give you an overview about how Germany is approaching artificial intelligence currently. So the first topic is Industry 4.0. I think Faisal told me that this is a term that is well known in Saudi Arabia as well. And the idea here is that you make intelligent networking of machines and processes for industry to provide flexible production, convertible factories, consumer-oriented solutions, optimized logistics by the use of data, and also by building up a resource-efficient circular economy. And the main drivers for this innovation are, of course, AI, but also for 5G and security. And I think that this is one of the important innovations that came out of Germany in the last years, that this term will shape manufacturing in the future, and that we can, to be honest, use these processes and the things defined here directly also in the field of medical applications, as you can directly apply these principles also to a hospital or any other kind of process where you are dealing with patients. The other thing is, which you probably know, is that we are strong in the automotive part. Quite a lot of famous brands in the automotive industry come from Germany, such as Porsche or Mercedes or BMW. And as you can see, also in terms of the revenue of the leading automotive manufacturers worldwide, here Toyota is still leading, but Volkswagen, which is a German company, is on place 2, and Daimler is on place 3. And those two companies alone share quite a large amount of the global revenue done in the automotive industry and are from Germany. And if you take a look at the automotive suppliers, then I think the number is even more staggering here, because like Bosch, Continental, and ZF Friedrichshafen are the 3 companies which are currently providing quite a lot of supply for the automotive industry worldwide. And all of these companies are based in Germany. And in terms of AI, well, I think this is something quite interesting. What you can see here is the number of patents in terms of which are targeting autonomous driving worldwide from 2010 to 2019. And what you can see here is that directly following Toyota Motor Company is Bosch, which is a German company on the 2nd place with quite a lot of these patents, and also VW is scoring quite well here. So what you can see is that Germany is doing quite a lot in terms of artificial intelligence, has quite a lot of talent, and by that, I think it's a strong partner. And let's again take a look at the medical field. A lot of these ideas can be applied there, as well as in terms of signal processing, the ideas from AI used in the automotive field can directly also be used in the medical field. I just want to give you a short idea of the political roadmap. So just that you have an idea what the strategic goals of Germany are in terms of AI. So there are 3 main targets. The first is that the political aim is that they want to make Germany and Europe a leading center for AI. The second idea is that they want to have a responsible development and use of AI, which serves the good of society, which I think is really important in the terms of the medical field. And they want to integrate AI in a society in ethical, legal, cultural, and institutional terms in the context of a broader societal dialogue and active political measures. And all these 3 ideas are together called AI Made in Germany. I think that's like one of the core market terms in terms of like advertisement that you will hear a lot if you see products from Germany. And what they stand for is especially that they use AI in a way that it is responsible in terms of the good for society, but also transparent in a way that you know what the product does for you, and you know what the idea of the product is, and how it serves your purpose. So I think that's quite important. And specifically in terms of like activities, I would like to highlight 2 things here, just again to focus on the medical field. In terms of research, what Germany does is we have now 12 centers of competence in AI spread all over Germany, and also 1 additional center for the working environment using AI. And they created 100 new professorships for AI-related topics. I think this is a very broad research focus in Germany, and something where you can see that it is really important, or that the political landscape is seeing and acknowledging the importance of AI and really shaping the AI research in Germany. In terms of targets, I think 3 targets are really important. The first is that the political strategy is to target an integrated software and hardware development to leverage the optimization potentials on the system level. And this is something I personally would like to highlight throughout this whole talk, that I think that only developing software here is not the only way to go. So I think software scales a lot. So that's the core reason and motivation to develop software and algorithms. But on the other hand, software will only run if the hardware is able to cope with the ideas proposed by software. And so I think an integrated development is really important, especially in the medical field, where you can see that a lot of the image processing requires a huge amount of hardware resources, and therefore it is really important to have an integrated approach. The second target is that methods for compliance checks of AI algorithms and recommender systems have to be developed. So I think this is more a software approach for like quality checks, and also that Germany is focusing on differential privacy to target all those people who are reluctant about the usage of AI in general. And in terms of applications in Germany, what you will see is that the core interests of the German economy are targeted, especially biotechnology and manufacturing. They also see it as a basis for cybersecurity and space technologies. And finally, one important part is that they want to use AI and data collection in medical applications in the interest of patients. So I think these are really important research activities. And again, I would like to highlight two things here just to give you the idea of what my approach toward AI here for the medical field is, that we have to have this integrated development in software and hardware approaches, but we also need to focus on the interest of patients and how they can profit of using AI. And yeah, let's go to the next part of the talk, especially artificial applications in the medical field. And the idea here is that I want to show that hardware is a foundation for innovation in medical applications. So let's take a look at what is the vision for medical applications. And you all probably have seen these visions and you have them on your own. Like we have a hospital which has mobile robots which can work on their own and help the patients, but also we have robots which are actually doing surgery and are used in hospitals. I think this is from Abu Dhabi, from Faisal, the image. So this is something that has already been employed in modern hospitals, but it is really important to see that these are shaping the way we are using the medical field. And I think there are 7 very important fields where we can use artificial intelligence in the medical field, namely radiology, where we can do image processing, then imaging in general, so taking images of the patients, improving the quality of the images, but also automatically finding diagnosis from the imaging. Then in general, disease diagnosis on a more broader scale, term is something that has really been driven by AI. Since disease diagnosis is one of these fields where you have to have data and you have to have the patient data and match them to find what the patient is actually doing. Then telehealth is, I think, really important, especially nowadays in times of COVID, where you probably should not always go to the hospital if you're only having a mild symptoms, and they can help you while you stay quarantined at home. So this is an important topic, also driven by AI. Also electronic health records, something nowadays also really important in terms of COVID, like that you have your own health records with you, that you can prove, for instance, that you are immune to COVID, and that you can move freely within the economic landscape and stuff like that. So I think these are really important topics for AI. Drug interactions is one important field where, again, lots of data are recorded, sensed, and processed. And after drug interactions, of course, we also want to create new drugs. And this basically is on the same paradigm of AI. But what is the basis for all these innovations that we are envisioning? And well, the basis is threefold. First, we need data. This is something you already have heard. We need data in the field of AI, and I think everybody's targeting that. So I won't talk about this today. Then we need algorithms. And again, this is something you probably have heard about a lot, and people are doing this. And I think that's a really popular topic, data plus algorithm, that gives us the solution. That is something you probably will always hear. But my claim is you also need hardware, because if you don't have the compute resources to process the algorithms and the data, then, well, basically, it doesn't help you if you can't move the enormous amounts of data required, if you can't process them, that's an issue. And this is why I want to focus on hardware in the following slides. Especially in the medical field, and want to highlight why hardware is such an important topic. And I want to show why hardware for AI has been a driver for innovation. And again, let's take a look on the revenue for the hardware, the AI-driven hardware market worldwide from 2018 to 2025. And as you can see, very similar to the market for software for AI products, also the market for hardware for AI markets is growing a lot by a huge margin every year. And I think this is both motivated from the actual need for these compute resources in terms of that the software market requires them, but it is also motivated simply from the advantages hardware gives you, because every new generation, just like in the 90s with the new CPUs, you can actually gain quite a lot of benefit from employing new hardware techniques. Let's take a more detailed look at the same figure. So that's like the same figure, just like the bars are split up into the separate fields. And so what kind of products are sold to the customers? And what you can see in blue, that's the largest share currently, but it has not been in recent years, are CPUs, ASIC, FPGAs, and SoC accelerators. I'm going to talk about that in a second. I would like to first highlight on the other products, their GPUs, so graphic processors. You probably all know them. This was the first powerhouse to train neural networks using GPUs, and this still is today in data centers. But GPUs, as you can see, their market the total amount of the total revenue will increase in the next years, but the market share will be reduced as the increase in CPU, ASIC, FPGAs, and SOC products in the blue products are increasing. And then you see we have a small amount of network products sold, and we also have storage devices sold. Of course, storage is really important, but at the end of the day, storage devices are not having that huge of revenue margin. So that's the reason why they have such a small share. Again, you might now ask yourself, what are CPU, ASIC, FPGA, and SoC accelerators? And if you are not from the field, these terms might be kind of vague. So I think CPU is something that you all know, that's your computer. This is what you all have at home, but I think ASIC, FPGA, and SoC accelerators are more a vague term for people who are not from the field. And the general idea of all these three is that you have a hardware platform which is specifically tailored towards the needs of the AI application that you have. So that you have an architecture, and what we call an architecture in the hardware market is a system of data processing and data movement. And this system of data processing and data movement is very much tailored toward the requirements of the application for neural networks, for image processing, and so on and so forth. And these specific solutions, as you can see, those have the highest share in the market in the next years. If you take a look now at the chip market revenue worldwide from artificial intelligence, what you will see here again is like the forecast is, it's really nice. It's looking like it is going to be even more important in the next years. It is already now have quite a high market size. But as you can see, this is motivating why hardware is such an important part, because only if the hardware scales, we can also scale up the algorithms and the data. And I would like to show you the final slide here, the estimated size of the artificial intelligence semiconductor market worldwide. As you can see, it will just increase. This is what you expect. But again, like, let's look at one specific thing, namely these application-specific integrated circuits, ASIC, what I told you already about before. And these are circuits which are specifically targeted to one aim, let's say, for example, for the medical field. And as you can see, also their revenue will increase in the next years quite a lot. And this is the thing where I think medical applications will be one of the important drivers of innovation again, because in medical applications, we have very specific requirements in terms of data processing and data movement. And we can solve these requirements by building application-specific hardware, which is able to cope with the requirements of the software systems. Let's take a look at the, in terms of the semiconductor industry market size, and what you can see here are well, just like the general 4-5 things that are sold. It's memory, microcomponent, OSDs, analog, and digital logic. And well, I think the important part here is just to highlight again, memory is basically data storage. So this is something we need in AI. Analog is, in a broader sense, data sensing, something that is really important in the field of medical applications for AI. And logic is data processing or data computation. So this is also really important. So what you can see here is that the whole set of well, data analysis and data acquisition that you will find in the medical field is also reflected in terms of the actual usage in the market for these three devices. So let's take a look where we can use AI and hardware for AI. And I think there are two important fields, namely inference and training. So inference is that you already have a trained system and you use it to, for instance, find patterns and to recognize if a patient is healthy or not. Training, on the other hand, is that we have a new set of data and we want to train the algorithm to be able to detect ill or non-ill patients. And these have very specific requirements in terms of what they do, because inference is a much easier topic. It is much easier to use it. You can already use it in your cell phones, but you can also use it in a data center for a larger scale, while training is a much more complicated topic. So let's take a look what is going to be here on the x-axis. And on the x-axis of this diagram are going to be the size of the amount of data you want to calculate and also the power requirements of your system. So on the one hand side, we have like data center scaled systems where you want to move a lot of data and compute a lot of resources. And on the other hand, we have your edge device like your iPhone that you're having at home, which also have to do AI applications. And it has way fewer resources in terms of computation and in terms of power. and also in terms of data, but still you want to use AI there. And the medical field will see all these 4 elements. We will have data in data center and on the edge, and we will have to use training and inference. In terms of market size, and I just would like to highlight this, all these markets will increase in size in the next years, but what you will see in all these slides is now that in terms of the market share, the application-specific designs will become much more important in relation to other ways of processing data. What you can see here for data center and inference, it will increase from 10 to 40%. It will decrease a little bit in training. That's in general. It will increase a lot in training, as the GPU share currently is basically 100%, and we expect that in 2025 it will be only about 40%. So also there they will be really important. And in edge devices, again, what you will see is that the ASIC market will increase in both inference and training tasks. And the important part where I want to highlight this is that there is a strong need for these ASIC devices, and especially in the medical field, they are really important as they can specifically target the requirements you need. So what kind of requirements are those? So let's focus again first on the data center. So the aim here is basically to increase the performance, both of inference and training. And in terms of research, what is going on there is the usage of spatial parallelism, so that you have parallel processing, exploration of sparsity, where you have 0 elements in your neural networks and you just don't want to calculate them at all because they don't carry any information. Then they want to reduce data movements, because data movements in general is quite expensive. And one very, I think, important example here is the Google Cloud TPU. So the TPU is a specific application-specific design from Google, which they already use in their data centers. And you can see this on the bottom slide here as an image. And it is speeding up inference tasks for Google a lot, and we all expect that these kind of architectures, which provide you with higher processing capabilities, with near memory processing to reduce the amount of data movements, and with 3D integration in terms of spatial parallelism, will be vastly important in the next years. And we see, to be honest, a quite similar trend at the edge, but the aim is completely different, because at the edge in your smartphone, you do not care that much about performance. Power consumption is much more the core of the game here. And how do you achieve reduced power consumption? For instance, by decreasing the accuracy in an acceptable way, again, by exploitation of sparsity, so that you do not do calculation for data that do not carry any information. You can also use spiking neural networks in comparison to convolutional neural networks. They provide better power consumption probabilities. And also you improve again the data flow. And here again, Google is one of the drivers of innovation, which just this year proposed or brought to the market the Google Edge TPU, which you can buy. It's the small chip shown at the bottom of the slide. And yeah, it's at the size of a Raspberry Pi. I hope you all know the Raspberry Pi. So it's like basically the size, same form factor. But the important advantage here is that it's a specific device which is tailored towards the requirements of artificial intelligence, and you can use it at the edge at very low power consumption. And this allows for integrated sensing and processing for IoT. And so what is the idea here in terms of medical applications? I think you all feel the game now. We will need both of these technologies to drive and further excel in medical application, in the medical field for the application of AI, because we both will need data center scale computation, because only at a data center scale computation we can actually, for instance, analyze of a whole population, how is a virus processing within the population. But on the other hand, we will also need very high performance edge devices, because if we have a robot which is working with the doctors at surgery, this robot will be an edge device, and it only has to do these tasks with a limited amount of compute resources, but still be sufficiently accurate for the best of the patient. So I think these are really important topics here, and as you can see, hardware is in general a driver for all of these innovations in all fields, and this is why hardware is such an important topic. And yeah, so to sum it up, hardware for AI is a key enabler in the medical field, from imaging, telehealth, or electronic health records. Just like 3 examples. In terms of imaging, we need large-scale data computation. In terms of telehealth, we need data sensing at the patient, which is still intelligence, so that we don't send all the data through the internet to the doctors and they only get presented the relevant data, but also in terms of electronic health records, we need to use data storage that we are able to work with. And this is why hardware is such an important field here. Yeah. And now we would like to focus on ways to benefit from the applications of artificial intelligence in the health field. And Faisal, I hope you're ready now to take your part. And yeah, I will still be in the presentation at the end. And I hope if there are any questions, I'm happy to answer them. Thank you.
Thank you, Moritz, for your talk. We will talk now about how to use AI in the medical field, exactly in the hospitals and for patients. We have summarized some use cases for pathology and for radiology and so on. So one of the most common use cases that we can use is the artificial pancreas. There are many uncountable factors which lead our pancreas to produce different amounts of natural insulin. The idea behind artificial pancreas is there are some sensors measure the glucose level, and this information will be fed to an AI-enabled complex algorithm. This algorithm decides how much insulin is enough to inject in the body. So the insulin pump will inject the right amount of insulin to subcutaneous tissues. The next one is about it's about the expert, how to use X-ray datasets and how to use AI in X-ray. It's about automated chest radiograph interpretation at the level of practicing radiologists could provide substantial benefits in many field settings. To run AI algorithm, we need to collect X-ray datasets in the computer, and the AI model has been implemented to convert these X-ray to a format image without losing their precision details. There has been around 350 X-ray images converted, and it has been sorted to serve a training datasets for next layer of algorithm. In the second layer, a complex AI model has been implemented, which takes current patient's X-ray image and try to search pattern or match in available training datasets to identify or help immediately to pull out the details about how much how a patient with a similar issue has been treated successfully in the past. This system can find patterns or match within 10 seconds. So the main idea in the pathology is to come up with a device which can easily be integrated with the current hospital infrastructure, and it can be used by staff. Pathologists will use an AI-powered microscope to get high resolution and detailed pictures. These pictures will be sent to the system, and preloaded AI model in either AI will perform the diagnosis, and results will be shared with the hospital staff in visual format. So the next medical application in oncology has the idea to eliminate human error by automating the process and have the virtual oncologist who has read through millions of pages, books, publications with milliseconds to get top-notch quality results. It's about Watson platform. It's an AI platform built by IBM, which has deep learning and large-scale data access and analytics capabilities. For given case, Watson can process millions of records instantly and can find patterns using deep learning capabilities to come up with accurate therapy for cancer patients. So the next use case or medical application is an AI-enabled system to address multiple patients in shorter time with accurate diagnosis. An example diagnosis from the system, which can be seen here. Most of the boxes show how the AI has labeled parts of the OCT scan, which means optical coherence tomography. But in the top left, if you see in the top left, you can see its recommendation and virus confidence in levels. So the idea, the function, the OCT will be used to create a 3D scan for patients' eyes, and this image will have details about tissues, which are completely used to assess eye health. CDS system has an AI algorithm which is trained with 15,000 OCT scans from 7,500 patients. This AI algorithm finds the pattern and present possible disease as an outcome.
Okay, yeah, thank you for these interesting insights, Faisal. And now I would like to just give like a short wrap up of the talk, what you've just heard. We focused on 3 topics. The first was the German experience of artificial intelligence and the areas of medical research. And I hope I could motivate why Germany is such a leader for AI, especially in terms of the talent and the research done. But I could also show trends and challenges for the AI in the medical field. And as one core innovation here, I showed you this label called AI Made in Germany, which stands for specific topics in terms of AI. The second field was artificial intelligence applications in the medical field. And I wanted to highlight that possible application fields need data, algorithms, and hardware. And then I showed different approaches to hardware for AI, especially the Google TPU, where Google has done a lot of research with these hardware devices. And finally, Faisal presented works on ways to benefit from the applications of artificial intelligence in the health field. And I think there were some very interesting applications which clearly showed that the applications can benefit patients and society, but also shape a health economy, which is much more productive than it is currently. And yeah, with these, we conclude our talk. Thank you for your kind attention. And I think we are open for any questions. So yeah, Faisal, just maybe you take care of that. Thank you.
Sure. Any questions? We got a question about what are the best resources for AI in medical field?
So could you more specifically clarify what you mean with resources here? So if you're thinking about resources in terms of data, I think we have to think about large-scale data in general. But if you are more thinking about resources in terms of sensing and processing and robotics, I think the important resources here are that we are able to build systems which actually help the patients in terms of these approaches. I hope that answers the question, but I'm not completely sure what you mean with resources.
Another question, as a medical student, how can I start to learn AI?
Oh, I think that's a very good question. And I think that the important part here is that you have to be open toward the innovations of computer science, and that you have to leave your comfort zone, which you have been taught as a medical student. And I think that the important parts here is to make yourself comfortable with statistics and the methods of statistics. And I think this is something that, well, that was a task of medical students throughout the last decades, but it has become much, much more important. And I think it is really relevant that you do understand how statistics work and how the data analysis work. And then based on that, I think you will be able to thrive in the AI field a lot, because at the end of the day, it's about that you bring your specific knowledge about the medical application, but you are able to discuss these topics with an AI engineer or a data scientist, in terms of that this person can tailor the solution to what your requirements. And yeah, for that, I think it's one core foundation is that you have a decent understanding of how the statistics works behind that, and how the data structure works, so that you can provide the data that finally can tailor the insights for the patients.
Another question, what are the challenges in telehealth?
Yeah, I think there are several challenges, and all these challenges at the end of the day go toward emerging technologies. If we understand emerging technologies as basically the three things, AI, 5G, and security, then I think these are the core challenges towards telehealth, because the patient has a right that his data are securely transmitted towards the doctor, because I think it is like one of the core things that the patient can trust that his data or her data will not be shared toward a third party that can abuse the data. The second thing is that 5G will enable quite a lot of IoT devices, and for telehealth, I think this will build an environment where we can actually provide quite a lot of data about patients, how they are feeling at home, their temperature, how they move. If they are disabled, we can help them to actually like use the IoT devices again to for instance, control their home. And I think this shows that 5G, or like being connected in terms of IoT, is one of the core challenges here. And the third challenge, as I hope I highlighted throughout this talk, is in the AI field, that I think only using telehealth in terms of the doctor can phone with the patient, that's something we have for like 20 years now, and it's not helping telehealth a lot, because phoning with the patient, that's not the core resource here. The core resource is that we have a system, an intelligence system, which helps the patient and the doctor to only transmit those pieces of information that are actually required for a useful diagnosis. And this is something that is mainly enabled by AI, where we have a way of sorting data, finding patterns, and by that presenting filtered data which are relevant for the doctor to make a decision on those data required.
A question, if we apply the AI about scanning and data collection for patients, how can we make sure about the accuracy of the patterns in application to a specific case of patients?
Yeah, I think that's a very difficult task in general, and I think there is no general purpose answer here which will give insight to that. I think the important part is that if we must make sure that the data sensing from the sensor side is accurate, and I think this is a conventional task that has been done quite a lot without any usage of AI. But on the other hand, we have to have a good understanding about the limitations of the AI algorithms, because if you want to find cats and dogs in a data set, I think it's quite okay if there are 3% error in there. But if you do the same for in a medical application, I think the story is quite different if 3% of the patients are getting the wrong treatment. And this highlights again that this is really relevant. And I think one of the important drivers for this is something that you found in the strategy for Germany. There was that they want algorithms that are transparent in a way that we know how the decisions are made from the algorithm point of view. And I think that is really relevant, because only if we have a transparent view about the accuracy of the algorithms and about the limitations, but also the potentials, then we can judge if this algorithm will solve our issue in a specific way, especially in a field where people's lives well depend on this decision making. So I think transparency is one of the important parts here, and this transparency in terms of algorithms and data management will, in my personal opinion, lead to a situation where we can better judge whether the AI does a good decision, and by that, this is one of the core factors regarding the data security.
Another question: as a computer science programmer, how can we find the medical challenges and to solve them?
Yeah, that's a question I think most of us have at some point. So how do we find those challenges which are relevant in the field we want to work for? And I think there is no general answer to this. Again, I think one of the important parts is talk to doctors and see how their daily life works and what they actually do as tasks. I think this is really relevant. And the other thing, I personally go to conferences, or well, at least as long as that was possible. I always went to conferences of other fields to find out about their specific requirements. So I think one of the options would be to actually get in touch with people working at the front lines, working at the field, and find out about their daily life, and then you have to listen. And if you listen carefully, I think you will find quite a lot of challenges, and will find quite a lot of applications where your specific knowledge as a programmer can be directly used to provide them solutions. So yeah.
Another question, as a data scientist, how can I get medical data to use for AI and machine learning to study them?
Actually, I cannot answer this question quite well. Faisal, maybe you might be able to answer this. I know that there are some publicly available data sets, like from the NHS in England, where they provided a longitudinal study of, I think, 500,000 individuals for quite a lot of data. So those are publicly available. Those data you can just download and work with them. And but specific data sets, I think, is quite difficult. You probably will have to ask somebody who is owning these data sets to provide them to you. But maybe, Faisal, you know more about that as you focus more on the application field.
Sure.
Yeah, just to wrap it up, I think the important part is there are open source available data sets that you can use, and they are quite good. Especially this NHS data set is really, really good. And will provide you with a lot of insights. But if you want to solve one specific task, at the end of the day, you will have to ask somebody who owns data to provide them to you. Yeah, I think that's like the answer in a nutshell.
Another question: there were reports to significantly expedite COVID-19 testing using AI to read chest X-ray. How accurate are these tests, and is AI tech capable to do that currently?
To be honest, I don't know the study, so I can't answer that. I'm sorry. So yeah, I can't answer that question.
So we got lots of questions, but because of the time, we can't answer them all at the same time. So apologize for everyone if we can't read his question. And thank you, Moritz, for your time.
Thank you a lot for your kind attendance, and I hope that you gained some value from the talk. Thanks a lot.
Thank you.